Hi, so this question 21 is about diffraction also along with interference because it also have two parallel slits. So let's review about diffraction and interference really quickly. The equation we need to use here, you can see lambda over b and lambda over d. So if you just check out the C3 formula in the data booklet, you will see these two equations. The very first one is like theta equals to lambda over b, and b here is the width of the slit. So whenever we got a really small slit, very small, about like millimeter or even like micrometer, and then you got a screen that is pretty far away from it for like 1 or 2 meter. So when we got the lights sent through this little one here, the little pinhole here, then you can see that if the light will get spread out and the spread be in color symmetry through the center line here, we mark the center position as the O, and then we also choose one way to be the positive direction, the other way to be like the negative direction. So you can see basically this is what we see on the screen, and they just show you what we see on the screen here. They also rotate this one, so you can imagine if I got the whole thing here and I kind of like rotate it around like this. Okay, that's what they want to show us in here about the intensity. So let me just like rotate it back here. Okay, so if you got the width of the pinhole is b, which is just like the distance within that pinhole here, okay, and then the lambda is the wavelength of the light of interest, then theta is this angle. Okay, what does it mean by theta? Theta is where the angle make between the center line, this one, and the position where you got to see the first minimum. Okay, the first minimum in the intensity, so where you will see it like dark. Okay, it's dark there. So if you see it here, we have the intensity drop down over position, and then it drops to like 0 at this position. You see that? So this is the theta of interest. Yay. So then basically it can be either A or C, right? Yes, this is the dark. Okay, and this is like the dark position from the diffraction itself. Okay, so if you only have diffraction, the light intensity graph should be like this. Okay, here we also got two parallel slits, so not just one, but you got actually two. So if you got actually two, you should have some other slit, maybe somewhere here, and maybe let me make it like we need to erase it, right? Like we have a pinhole here. Okay, so you have carved another slit here, and that slit also have a width b, but the distance between the two slits will be the d. Okay, can you distinguish between b and d? B again is the width of one slit itself, and the d here is the distance between the two slits. Okay, and this is the little d. In those kinds of problems, we also have another notation for the big distance between the slit and the screen should be the big D. So I just want to emphasize that the little d is like the distance between the slit. Okay, you can have more slit that will be applied for diffraction grading. In this one we just have two. So because we have two, so in besides the diffraction pattern, we also see the interference pattern as well. Interference pattern. And for the interference pattern, you got the equation n times lambda equals to the d times with the sine of the angle theta. So again, the theta, also the angle is made between the center line and any position of interest we're talking about. Okay, so it should be somewhere, you see it within that dark, so it should be somewhere here and here. Okay, you got some theta here. And what does it mean here? This one will be for the pride fringe instead. This is the pride position when you see the intensity is not zero. Okay, so if you can see here, the center point will be the maximum. Okay, it's the brightest spot, the brightest position on the screen. And then after the bright one, you come to a dark one here because that's the destructive interference, right? It's dark here. And then when you just move a little bit, then you got another bright and another dark, another bright, another dark, another bright, another dark, another bright, another dark. And when you reach to the angle like 0.05, you got another bright. So how can we distinguish between on the prime fringe? Then we name the n. The first one here at the center will be the 0. Okay, and then the first fringe away from the center will be n equals to 1. If you go the other way, then it's minus 1. Okay, this is the minus 2, this is the minus 3, this is like 2, 3, 4, and 5. So you can pick any values, the coordinates, not like coordinate, but a combination of the n and of the angle. So let's just pick this one because we have it like 0.05 ready, which is equivalent to the n equals to 5 here, right? So basically you just plug it in. 5 times lambda equals to d times psi of that 0.05 radian. That's the measure of the angle theta. And then here they ask us to find lambda over d. So basically this is lambda over d equals to what? Because those angles here, I wanted to also mention this. The angle here is pretty small in reality. It's not that big like we draw in here, This is not to scale. Actually, the angle is very, very small. And when you got a really small angle, the angle itself will approximately equals to the sine of it. So this one is actually almost equals to 0.05 times width divided by the 5 here, right? So we got it to be the 0.01. So that's why we got the answer to be the C. Okay, so basically for this question 21, you have to got to know how to use the two equations listed in the data booklet. This one is for the dark, okay, and this one is for the prime fringe. This one is for interference, and this one actually for diffraction. Sounds good? Please let me know if you have any question. Thank you.